Here we go with the lesson. Are you ready? There's the warm-ups. We did these for warm-ups. All right. Here we go. Your notes are on the end of set 115's notes. This is partial fraction part 3. So they are blue. I think the title is something like set 115 partial fraction of the decomposition. It's on the back, the bottom half. In the night, what you got going on tonight? All right, here we go. This here is a integral that cannot be u-subbed or integrated in any normal fashion, and so we want to partial fraction it. This guy here is called an irreducible quadratic. It cannot be factored over the reals. If you have a case like that, then you decompose it with a little special technique Miss Cannon taught you. If you get an irreducible quadratic, you can't just slap a normal old a up top. You've got to set up a kind of a u-sub problem, and it's got to be ax plus b as the numerator for an irreducible quadratic. That is the only thing that gets you out of the morass and gives you a solution. Plus, then a c, a normal c could be for the other term, which is, you with me on that? All right, the partial fraction part is a little uglier, and the integration is a little uglier, so let's continue on. 4 equals the sum ax plus b times x minus 2 plus c times the sum of x squared plus 2. If we clear the fractions. What shall we let x equal? 2. If x equals 2, then 4 equals c times 5. So c is 4/5. All right? Now you can see that there is no x that cancels that out. Well, at least not in a real x. We could use what x would work. Yeah, you could use an I there, but we don't do that. So instead, let's focus more on the matching coefficients aspect. If I look at the squares, how many x squareds on the left? 0. And how many x squareds on the right? Yes, and what are they? A plus cx squareds. Now we know that c is 4/5, so a must be negative 4/5 in order to zero it out. Yes? And for x? Yes, you could. So in essence, then you're saying the constants, if you let x equal 0, then you're really focusing, despite no matter what you think of it, whether you think of putting an x0 in or saying focus on the constants, however you look at it, do you agree that 4 equals negative 2b plus c? You follow? And that's the same as putting in an x of 0. If c is, what I say is c is 4/5, this I'm going to have to go a little slower because it's pretty gross. I get 4 equals negative 2b plus 4/5. I would subtract 4/5 over. What's 4 minus 4/5? 3 1/5 or 16/5. Divide by negative 2 or multiply by the reciprocal, and b is negative 8/5. Are you with me on that? All right, now we're ready to integrate. Our integral can be rewritten as the integral of ax plus b, which is negative 4/5 x minus 8/5 over x squared plus 1. And the integral of, I'm just going to do this in separate integrals. C over x minus 2 is 4/5 over x minus 2. Stop me if you disagree. All right, what about the first integral? How are you going to do it? U sub is correct, but if you go at it the whole way, u is x squared plus 1, but du is 2x. So you've got a bit of a, you got the x to the first, but the negative 8/5 makes things a little gross. So what should you do? Yeah, this needs to be split again. And that's before u sub. So I'm talking negative 4/5 over x squared plus 1, and negative 8/5 over x squared plus 1 as separate integrals, and then the last guy 4/5 x minus 2. See where I'm coming from? All right, so that first one, do you actually want to use sub or just kind of mental use sub? All right, so negative 4/5 can be brought out front. If u is x squared plus 1, then what's du? 2x. And so does that mean it's a 2 out front or a 1/2? 1/2 of, then it was 1 over u, the antiderivative of which is natural log of x squared plus 1. You see where I'm coming? Yes. All right. The next one, what's the antiderivative of that? Inverse tangent, yeah. Negative 8/5 inverse tangent of x. And then the last one's a typical log kind of question. 4/5 log of the absolute value of x minus 2. All right. There, we could do the u try, but there are 2 on the homework. So let's do the 2 on the homework instead. So would you go to 6 is the easier one, then 7 is the harder one. So let's do 6 first. I made a mistake. You want to switch the... I don't know. It's a tough call. Let's do actually. You do 6, and I will calculate an area for you.
It's a nice review.
Yeah. Well, I do this every day. It's little kids tell me still learning how to use a ruler. Actually, box 7 is bigger by 5 square centimeters.
Is box 6 longer than?
I don't know. I assume because 5 didn't require that much room, so I was trying to help it out. Now I'm threading it.
No, thank you for starting box 6.
You're welcome.
Sure,
7's lot. Oh, there's a couple of gotchas in. There's my decomposition for 6. Do you agree to x plus 1 over x squared plus 1 and 1 over x minus 1? All right, I'll assume that's a yes. Okay, do you have something like that? Yes? All right. 7 is a little tougher. We got a few problems, at least one problem to think about. What's that? Oh, sure. Arctangent is negative. Did you get a positive one here? Do I have to, should that be negative one? Where are you getting a negative? I'm not saying no. I just made a mistake maybe, but I don't see where. Here. That's not negative? Oh, okay. I thought maybe I copied it down. So we could. Okay. Okay. So. The you agree with that decomposition? X plus 1 over x squared plus 2 and negative 2 over x plus 1? Is that a yes? Okay.
Yeah, it's yes.
Okay.
I just overcomplicated that way too much.
It is because you're doing it all in your head.
No,
No, I assure you, when looking at your work, you do more of this in your head than anybody else in either class. Legit.
that's what I'm working on.
I don't know. Just so you're aware, typically I would grade this based on, I wouldn't look at any of this. I would just say, did you decompose it right? And that would be about half the points. And then I would have to integrate whatever you got for the rest of it. And did you integrate right? So, I mean, if you can do all this without work, then that's on you. Yeah, so that's the problem. That arctangent is not awesome. I can do the first and the third ones just fine. That, to me, is easy enough. And that's easy enough. But that one, so I did it this way. X squared over 2 plus 1 dx. So u squared is x over 2, u is x squared over 2, sorry. U is x over root 2. Du is 1 over root 2 dx. So root 2 du equals dx. So with substitution, it becomes something like 1/2 root 2 du over u, u squared plus 1, excuse me, u squared plus 1. So in the end, I get root 2 over 2, or 1 over root 2, arctangent of x over root 2 there. I did it kind of in the middle, which I don't know if that's great math. You could maybe go off to the side and do it. As long as your work's clear. Are you with me? You follow? All right, that's pretty gross. That's no, I would say that's as gross as it gets, but it's not. You can have it. So there's it's gonna be worse. All right, but that's for later date. Let's talk about last night's homework and start by focusing on the AP question, which was a humdinger, whether you know it or not. So let's see how this went. A is one of the harder things to justify in a Calc 1 problem. It's absolute extrema without a closed interval. I know Miss Cannon kind of teaches it like treat end behavior as an endpoint. I was not taught that way. It's definitely not what I learned in college, so I don't do it that way. I don't know for sure what a college professor would say generally, but I know my college professor would say infinity is not an end at all, so don't treat it like an end behavior or an endpoint. But another college professor might have said something different. This, if you're proving an absolute max without endpoints, you have to use what's considered strong language in math. Now, I'm not talking cuss words. Effing right, this is a max or something like that. I'm talking like only this or for all that. Those are super strong words in math. Only and for all. That's the way I'm going to go with this. So this is the way I did this, and feel free to, I can look over your work if you like. But first and foremost, the EVT doesn't really, the first part of the EVT doesn't apply because we're guaranteed absolute max is guaranteed if it is continuous on a closed interval. That's the first part of the extreme value from those two parts. This is not on a closed interval. That means it's not guaranteed to have an absolute max and min. That isn't to say that it can't have an absolute max and min. For example, y equals x squared. Does that have an absolute min? Yes, but it doesn't have an absolute max, all right? So things can have an absolute extrema without meeting those conditions. They're just not guaranteed to have one. So the guarantee is not applicable. It could still have an absolute max if it has continuous continuity over a closed interval. Then the absolute max must be at an endpoint or critical number. This doesn't have endpoints, so that part's not applicable either. Let's start with the first derivative, and then we'll go there. First of all, check your quotient rule. Low, d high minus high, d low over the square root of low. Do you get something like g prime is 4 minus 16x squared over 1 plus 4x squared quantity squared? I don't know if you factored that, but I called it 4 times 1 plus 2x, 1 minus 2x. The denominator doesn't factor over the reals. This then has critical numbers at where this is 0 undefined. X equals negative 1/2 is a critical number, but it's not in the domain of the function they give us. So x equals 1/2 is the only critical number for the domain prescribed. All right? Now let's talk. I am going to use a sign test. I understand it's not a relative extrema problem, it's an absolute extrema problem. But I'm still going to get a sign test to give me some kind of... All right, so there's one flat spot in the graph. What's going on around that flat spot? Well, before, I think you'll find that g prime is negative, and after, nope, g prime is positive, and after is negative. So if I were to make a doodle of this graph, the graph is increasing all the way up to 1/2, where that is the only place it has a critical number, and then is negative for all x forevermore after. So what must be going on there? It's an absolute max. Now, you would actually have to be very thorough to say that. If you said G has an absolute max of G of 1/2 equal 1, I think it is, because G prime is positive for all x less than 1/2 and negative for all x greater than 1/2, you'd be on the right track, but there would still be a hole in your argument. Here, I'll give you one. What if it looked like this? And it looked like this. Is that actually, does this satisfy what I said? Is G prime positive for all x's less than 1/2? Positive? Positive. And is it negative for all x's? Yep. But is that the absolute max? Nope. And so you need to say a little more. You would have to say G is continuous on 0 to infinity. And then G has an absolute max that's positive for all x's in the domain before, and negative for all x's after. This would be an absolute max. Powerful language like for all and only, those are the key. You might, there's one strategy where you say it's only got one critical number, and it's continuous. So you might have said something like that. These, honestly, are one of the hardest ones to teach, and it's a freaking nightmare to grade. That's why they've done one of these in the last 20 years, because it was such a pain to grade. They said, forget that nonsense. All right, B is better because it has yesterday's improper integral action, but I would be excited to see if you got the answer or not. So let's go here. Did you get the graph looks like this? 1 over x is on top. Oops. And this, I think it's actually, here's g equals 4x, so it has a 0, doesn't it? 4x over 1 plus 4x squared on bottom. Does it look something like that? Doesn't matter if you have a graph, right, because they tell you what's on top. Here's 1. Here's the area between. Okay, so I'm visual, so if I can get a picture at all, I gotta get a picture. So I had a picture, it looks something like that. They would probably start giving you points based on the integral. What's the integral for the area? From 1 to infinity of 1 over x minus x, is it 4x or x? 4x over plus 4x squared. That would probably be 1 point right there. I can't find the rubric. I can't remember what year I pulled this from, sorry. But that's a good start. Then the idea would probably be something like, did you write a proper integral, which is to say from 1 to a for x? If you didn't, I would probably not even read any.
What if we didn't do your first step, which was interesting?
I can't remember the rubric. It'd probably be okay. Let me try to find the rubric. I can't see it. All right. This one anti-differentiates pretty well. This one's kind of funky. It's u sub, right? But you got limits there. So I have 2 strategies I could consider. I could split the integrals and do the u sub, changing the limits, or I could just go off to the side and find the antiderivative and then bring it back and deal with the limits. What do you want to do? Antiderivative off to the side or split and change the limits? Off to the side. I think that would be the best way to go. If you anti-differentiate this, it is u equals 1 plus 4x squared. Du is 8x dx. If you don't mind, I'm going to say that means that 4x dx is du over 2. Are we cool? Therefore, that is du over 2 in the numerator and u in the denominator. So maybe 1/2 natural log of u, which is 1 plus 4x squared. Because that's positive, I didn't use absolute value, but you could have absolute value. You with me? All right, therefore, by that logic, this definite integral is equivalent to natural log of the absolute value of x. Actually, it's positive territory, so you could leave that absolute value off too. Minus 1/2 log of 1 plus 4x squared from 1 to a. Are you still with me? Are you succeeding? Okay, the hard part, the gotcha's coming. So, the limit as a goes to infinity of natural log. Did you combine these or just keep it separate? Keep it separate. Okay, so natural log of a minus 1/2 natural log of 1 plus 4a squared. All that, subtract natural log of 1 minus 1/2 log of 5. Okay? You tracking? So here's where I bet you said this is infinity. Oh, I stop and it diverges. And that's where you just lost. It does not diverge, it does converge. This is infinity, yes, but this is also infinity, and that is not diverging. That's indeterminate. You need to do more. More. Okay? So you should not have stopped the minute you saw an infinity. You should have said, okay, I need to proceed on with the seeing more, and say something like, this is the same as, if I get infinity minus infinity, I need to make it some kind of ratio comparison-y kind of case, yeah? How could you make this a ratio comparison? Log of a over square root of 1 1 plus 4a squared minus, this is such a mess, I don't even know what I wrote here. What does this say? Oh, that's log of 1 is 0, and that's minus negative, so that's plus 1/2 log of 5. You follow? Are you with me?
Yes.
Okay, here we go. Now we're using a little in behavior knowledge. Overall in behavior, the top is a. The denominator, the 1, doesn't matter so much as a gets big. The bottom starts to approach square root of 4a squared, or 2a. A over 2a would approach log of 1 over 2 plus 1/2 log of 5. That's your answer. Or you could combine more problems. That, to me, is a great problem. It has a lot of different calculus. It's got U sub, it's got indeterminate forms, it's got improper integrals. That's great. Great problem. Great. Okay? All right. Questions on 125. Don't you appreciate a great problem? We did that one in class. Questions on 125? These are 13. Now 13, I gave you 2 boxes, all with the grand, actually. But 13, the 2 boxes work out great if you use 1 box for the circular integration and then 1 box for the improper integral part. Yeah? So, that's what I'm going to do. 13 part 1, find the antiderivative using circular integration. And then in the second part, I'll use my antiderivative to do the improper integral component to it. So right now I'm just going to focus on the antiderivative. Are you cool? Is this circular or tabular? Circular. It is circular. It can't be tabular, really. I should have said this right off the bat. It really can't be tabular if it never terminates. And this never terminates. So it's circular. What do you want to let u equal to start with? Cosine or e? I don't care which, just be consistent. U is cosine, okay. dv is e to the negative x dx, therefore du is negative sine. And v is negative e to the negative x. I can tell you there's negative all over the place in this problem. Be very careful and neat and organized. uv is negative e to the negative x cosine of x minus v, negative e to the negative x du, negative sine x dx. Okay? I have 3 negatives there. I'm going to take those 2 negatives in the integral and make that a positive if you don't mind. My next substitution, let's go consistent. U is cosine before, now U is going to be sine. dv is e to the negative x again. du therefore is cosine of x dx, and v is negative e to the negative x. Are you down? Negative e to the negative x, cosine of x, minus bracket uv is negative e to the negative x sine of x minus v du, negative e to the negative x cosine of x dx. That, with all negatives carefully distributed, is negative e to the x, negative x cosine of x, plus e to the negative x sine of x. And what about that last one? Plus or minus? There's 3 negatives there. 1, 2, 3. So that's all together negative e to the negative x cosine of x dx. When you then combine that with the original problem, 2 e to the negative x cosine of x dx equals negative e to the x cosine, negative x cosine of x plus e to the negative x sine of x. See, so our antiderivative is negative e to the negative x cosine of x plus e to the negative x sine of x all over 2 plus c. Are you down? You cool? Great. Okay, so now let's go to part B. The improper integral. The limit as a goes to infinity of 0 to a of that integral is equivalent to the limit as a goes to infinity of that antiderivative, negative e. Let me just pull the half out front, do you mind? Okay, limit rules are cool with that, by the way. If I pull that half out front, or divided by 2 out front, negative e to the negative x cosine of x plus e to the negative x sine of x from 0 to a. Cool. 1/2. Limit as a goes to infinity of negative e to the negative a cosine of a plus e to the negative a sine of a minus negative e to the 0 cosine of 0 plus e to the 0 sine of 0. My goodness, this is a humdinger. All right, 1/2 stays. As a goes to infinity, what is negative e to the negative infinity approach? E to the negative infinity goes to 0. This oscillates, but does it matter that it oscillates considering that e is going to win? It's going to be 0 times oscillating. That's definitely going to 0. Same with this. This is e to the negative infinity. And yeah, sine of a oscillates, but e to the negative infinity dominates. That's 0. Minus negative e to the negative 0 is negative 1 times cosine of 0 is 1. So all said, this is 1/2. That was big. That was rough. Big. All right. Have a lovely day. Be nice people. Teachers with respect and love. Yes. Who else asked me that? Did you ask me that? Somebody asked me that. I couldn't remember who it was. Who did you just ask me that? Right? Somebody asked me that. Strangers in the night, exchanging glances.